Alright, so today we're going to learn about one of the most important differentiation rules in calculus, which is the product rule. Now, the product rule is really important. It really simplifies many other things, many other factors that come into uh, consideration when solving polynomial equations. Any product, any equations that are product of each other, deriving to many complex equations that are a product of each other. So by the name itself, it shows you that it is some sort of product of each other. Uh, the definition of the product rule says that if h of x, if h, let me just, if h at x, if h at x is the product of f at x times g at x. Now these are two other functions. Uh, Now they could be any function as long as they're differentiable. Uh, Differentiable functions are different. Anything that is basically can be differentiated. That's it. Now, consider these as being a parameter uh, as long as they don't be infinity over infinity or 0 to the power of infinity if you plug to anything like if you plug in infinity in x, then this is what the output you get, and many other factors. So I get these from the L'Hopital's rule. Same thing applies to this. It's gonna be infinity over infinity, 0 to the power of infinity. These give us something that's not differentiable. Now, now that you get the concept of like what it's gonna be like, basically you just have to take these two functions and take the derivative of each of them, knowing that both of them are differentiable. Now, this is what the product rule says in an equation format. So h of x, derivative of h of x is equals to the derivative of the first term f of x prime times the original second. Now this is the original g of x plus the derivative of the second term times the original first. Now that's in a nutshell pretty much what the product rule is. And as long as you're able to apply this equation pretty much everywhere, you're good to go. You can get the differentiation equation by just applying the product rule. Now, the application of the product rule is another thing. You need to practice it. It doesn't come by just by out of nowhere. You have to practice. If you don't practice, unless you're some smart dude who just know how to do it, you're good to go. So practice is an essential thing for pretty much anyone. Practice makes perfect. I think that's a really good saying. So let's just don't waste any time and do some work. So number one, let's take an example. Let's throw f of x is equals to x plus 7, x plus 7 to x plus 5. Now this is really easy. We just follow the same pattern that we did over here. So we have h at x prime, we have f at x. So just following this pattern. So let's say this is f at x, and let's say this is g at x. G at x. Now just mash this to that, mash this to that, that to this, and then you're done. So finding the derivative of f at x gives us the derivative of x plus 7, which is this thing, which is 1, times the original g at x, which is this, to x plus 5 plus the derivative of g at x, which is 2, times the original f at x, which is x plus 7. So that was a quick way to solve product rule. Now let's do another example. Example 2. Now usually polynomials are pretty easy in applying the product rule, and usually it's most of the time polynomials that come across using the product rule. You have to use a product rule in polynomials because the way how it's set up, in the end, it just comes down to using it with the product rule. 6 minus x. So we're finding the derivative of g at x. So we have the first term, we have the second term. Let's say the first term is f at x, second term is g at x. We know what was the equation. So f at x derivative times the initial g at x plus the derivative of g at x times the f at x. So let's do it quickly. Find the derivative of f at x, which is 8x times the original g at x, which is 6 minus x, plus the derivative of 6 minus x, which is this. It's negative 1 times that by the initial f at x, which is 4x squared, minus that by 3. So now that is the g at x prime. Let's do another one really quickly. 8x plus 1. This is p at x, which is equals to 8x plus 1 times that by negative 2x plus 3. Now find the derivative of p at x is equals to the derivative of this thing, which is 8 times the original of this one, negative 2x plus 3, plus that by the derivative, the initial, the derivative of this one, which is negative 2 times that by the initial of this one, which is 8x plus 1. 8x plus 1. Now, if you do this about 5-6 times, you're set to go. You know how to do it. This is that easy. This is that simple. But also, this is a really powerful tool in calculus. Understanding how to use the product rule. Understanding the product rule is a really essential thing because you'll be applying this in the quotient rule, in many other problems that you come across in calculus. So thank you very much for watching my video. Please rate, subscribe, and please comment. Give me some ideas. What do you want to know? How can I improve these videos?